Hello, today we'll be covering cartilage. Okay, so cartilage is a special form of connective tissue that provides strength and flexibility. It's lined, or certain types, I should say, are lined by the perichondrium and dense irregular connective tissue. Let's see, except for the articular cartilage, it does not have the perichondrium. Cartilage is made out of chondroblasts, chondrocytes, and the extracellular matrix. The cells come from embryonic mesenchyme. There are no vessels, no lymphatics or nerves in the cartilage, which is a little bit problematic when it comes to healing. Nutrients will diffuse through the synovial fluids or the vessel of the perichondrium, so only a certain amount of chondroblasts and chondrocytes are going to have a lot of direct access to nutrients. The chondroid matrix is the extracellular matrix that has a lot of fibrous proteins and type 2 collagen. It's primarily made out of ground substance, which is proteoglycans, hyaluronans, sulfated glucosaminoglycans, and adhesive glycoproteins. The chondronectin will bind to GAG along with type 2 collagen and the integrins. 75% of it is made of just water. It's gel-like. It reduces stress on the joints and it works with lubrication. And under load, water is squeezed out. And once it is removed, water is uptaken. And the collagen fibers will prevent the proteoglycans from expanding completely. As you can see here, there's the different types of cartilage, but they're all kind of they're all similar in the fact that there's a lot of ECM around and kind of isolated chondrocytes or chondroblasts, and it's not very vasculated at all. Okay, so the chondroblast will undergo one or two mitotic divisions, like the proliferative zone, and they synthesize components of the ground substance during the divisions and become chondrocytes as they are enclosed by the ECM. The chondroblasts and the chondrocytes will have the protein-secreting organelles, like the ribosomes, and the chondroblasts are, as you can see, round, and then eventually they kind of flatten out. And they stay in isogenous groups like this, which all arise from one parent cell. Chondrocytes maintain the integrity of the cartilage matrix by synthesizing and secreting cartilage matrix throughout its life. And the territorial or capsular matrix is just the ECM immediately formed around the lacuna. It's actually right here and right here. It's the darker area. It's rich in GAGs, which was why it stains darker. And the interterritorial matrix has a lot of collagen fibrils. It's less basophilic, so it stains lighter. Okay, so hyaline cartilage is the most common cartilage. It makes up nearly all of the fetal skeleton. And in adults, it stays as the cartilage of the nose, the larynx, the thyroid, the cricoid, the arytenoid, the trachea, and the bronchi. The articular cartilage doesn't ossify, while the costal cartilage can, and is usually because of age. Chondrocytes are round and found in isogenous groups, and they're all scattered with collagen fiber type 2. The articular cartilage has more collagen than the other types of hyaline cartilage. It works in load distribution and decreasing friction. And this does not have perichondrium. It's partly vascularized because it's getting it's just indirectly, because the vascularization is really for the bones, like the bony structure that it's covering. And the zones, and this is the epiphyseal side down into the diaphyseal. So this is going to be the epiphyseal plate. So first there's the first zone, which is the zone of resting cartilage, and where the cartilage attaches to the epiphysis, and then the zone of proliferation, where cartilage is produced on the epiphyseal side. The chondrocytes will divide and form stacks. And then zone of hypertrophy, the chondrocytes will mature and enlarge. And then the zone of calcification is where the matrix is calcified and the chondrocytes die. And then lastly is the ossified bone. The calcified cartilage on the diaphyseal side is replaced by bone. So oddly enough, at the epiphyseal plate, it grows inwards, So this is how the bones lengthen. Hyaline articular cartilage tide mark is right here, and it's a calcified line separating the calcified zone from the upper zones. And it's also a plane of weakness. Duplications with agings can be seen, and the calcified cartilage is gradually replaced by endochondral bone formation, and the calcified zone will push into the upper zones. A superficial laceration above the tide mark will force the chondrocytes to proliferate, but there's still no healing because there is no vasculature. But continuous passive motion has been shown to help with healing. And deep laceration below the tide mark will heal, but it forms a fibrocartilage scar. Elastic cartilage has very little collagen, has more elastic fibers, and they branch in all sorts of directions. And it's a network of interlacing fibers. And it's particularly dense near the chondrocytes, which is why they stain quite dark. And it has a lot more ground substance, and it's found in the pinna, the larynx, the epiglottis, the cuniculate, the arytenoid apex, and the external auditory canal. And this one does not ossify at all. Fibrocartilage is the strongest out of all of them, the types of cartilages, and it's made of chondrocytes and hyaline cartilage matrix mixed with a dense connective tissue. It resists compression and shear forces, and look how nicely organized it is. It's found in the pubic symphysis, the menisci, the glenoid or the acetabular labra, the temporal mandibular, the sternoclavicular, and the sacrococcygeal joints. It's also found in the annulus fibrosus, while the nucleus fibrosus has a little bit of fibrocartilage, but it also includes hyaluronic acid. That's why it's still jelly. The ECM has minimal amount of ground substance. Fibrous component really dominate, and type 1 collagen is secreted. Okay, so there's two different kinds of growth: interstitial growth and appositional growth. The activated chondroblasts will make the ground substance that surround and push them apart, and they divide by mitosis, and then they get trapped, and then they turn into chondrocytes. The lacuna forms, the chondrocytes undergo mitosis, and they make the isogenous group, and they make a new matrix that replaces the matrix around the group, making the cartilage longer in interstitial growth. And that only really occurs in young cartilage, and as adult you can only have appositional growth. Mesenchymal cells of the chondrogenic layer of the perichondrium will just differentiate into the chondroblasts, and those will deposit matrix on the surface of the existing cartilage and increasing the width. So this would be appositional growth, and those occur in both immature and mature cartilage. As you can see here, interstitial growth happens within the bone. Appositional growth was really within the perichondrium. Okay, so these are the different hormones that affect like bone density, which also affects cartilage proliferation. As you can see here, ACTH, FSH, LH, right? This is for the women, growth hormone, and corpus luteum. That's for during pregnancy, and that involves the ovaries, testes, testosterone, estradiol will involve the estrogen and progesterone, and those affect the nervous system and also collagen production. So here, collagen is made, and those would affect ligaments and tendons along with the articular cartilage. The perichondrium surrounds all the cartilage except for the articular cartilage and the fibrocartilage, and the outer fibrous layer is made out of the dense, irregular connective tissue, and it contains the fibroblasts, which produce collagen fibers, while the inner layer has a bunch of blood vessels, the chondrogenic cells, and the chondroblasts. It's less prominent after the cartilage is fully developed, and it functions in appositional growth along with the repair of cartilage ish. And I say ish because cartilage has just very limited. Um, Usually there is just there is no healing. It involves a surgical intervention, and with surgical intervention it's usually replaced with fibrocartilage. That's it for now. Thank you for your attention and good luck studying.